Hello, welcome to this session on Clash Detection API. I am Prashant Anantharam, a software engineer working in the iTwin platform group, and in this session, I'll be talking about the Clash Detection API's capabilities. In this session, we will touch on Validation API in general, that is, how the Validation API enables you to perform data quality checks on your digital twin and the types of validation you can perform with it. Then we will review clash detection and its API in a bit more detail, talk a little bit about suppression rules, and build a simple iTwin UI application that uses the clash detection API. At the end, I'll also provide links to samples and tutorials to get more information so you can build an application that would suit your workflow. So what is validation platform and how or where does it fit in the project or the asset lifecycle? The validation platform enables you to check a digital twin's data quality and generate reports which can be used for further review and provide feedback to the design teams. So this could potentially fit in the project's review stage where you can build applications to generate validation reports which can be further used for data analytics or for creating issues or service requests for the design team to iterate over the design and fix problems, if any, before it reaches the construction phase, thereby saving time, money, and effort. There are two types of validation API we provide today. One is property validation. So for example, if you need to determine the carbon footprint in terms of energy expended to manufacture and install a component within an assembly, we need to know certain material data that is associated with the component in the digital twin. To calculate the carbon footprint, certain element properties within the digital twin should have the necessary data without which the carbon footprint cannot be computed. Or for example, a pipe's insulation thickness should be within a certain range without which there could be overheating causing a component breakdown and can be avoided in the review phase of the project itself by running property validation checks. I should note at this point there is a separate accreditation course highlighting some of the features of property validation API, and I'll share the link to that resource at the end of the session. It goes into detail about the API offerings we have there and a sample application to showcase its capabilities. The second type of data quality check which we will be focusing on today is to perform clash detection checks between different disciplines and between different design categories, along with the ability to define schema-based suppression rules. The iTwin Clash Detection API checks for geometrical collision between various design element groups in the digital twin. In general terms, this involves checking if the geometrical extents of design elements are colliding or coming under clearance limits with other geometries in the digital twin. Clash tests define two sets or groups of design elements based on engineering models or categories defined in the digital twin. For example, all design elements for mechanical equipment can be part of the first group, and all piping elements can be placed together in the second group. Clearance around a design element, for example, all pipes must have 6-inch clearance for insulation requirements. So if there are design elements that are not physically touching each other, but they are within the specified clearance distance, they will be marked as clearance clashes. If design elements are physically clashing, they'll be marked as collision clashes in the clash report. There are a couple of advanced options like suppress touching with an ability to define tolerance to suppress clashes when two design elements are touching each other. For example, a steel beam and a steel column touching at the connection. They are not necessarily clashes, so they should not be marked as such. Of course, the API gives the user the flexibility to define such options. Coming to suppression rules, they are basically suppression criteria and are defined as logical rules. For example, if all clashes between a wooden door and a concrete wall should be suppressed, they can be identified and marked as such by defining suppression rules. With this background, I think we can start the demo. In this session, we will review the clash detection API to create a clash detection test, run a test and generate a clash report, retrieve the clashes and review the JSON data in the report, visualize the clashes, create a suppression rule, update a clash detection test with the suppression rule, and run the updated test and generate a new clash report and review the clashes. Go to the iTwin.js tutorial webpage and select the web viewer under the Start Applications. Here you'll find instructions to bootstrap a web viewer application. So I followed these instructions, registered a single page application, and selected iModels and Clash Direction API scopes for the application that I plan to build. For this demo, I cloned the Coffs Harbour iModel by using the link here. A new iTwin ID and an iModel ID was generated. You can add the project participants here so other users who you like to have access can be added as well. I will switch over to the code base and in the env file, update the iTwin ID, the iModel ID, and the selected scopes, and go to your command shell and start the application. As you can see here, the application is started, and in the visualizer we can see the Coffs Harbour model and the model and category tree widget on the right-hand side. Now that we have set up our base application, I can begin to consume the Clash Direction API and build components around it. To begin with, I'll go to the Developer Portal's Clash Direction API section. Here we have a subgroup that provides the user the CRUD operations for clash detection tests. A clash detection test basically stores the criteria to identify the groups of elements that the user is interested in. These groups of elements can be specified either by identifying the categories and or the models they belong to, or even specify an EC-SQL query. So we need to create two different groups that we need to check against, and this is what is called as a test. So it is time to create a test. I'll switch over to my code editor and uncomment a few lines of code and hit save. I will switch back to the application now, and now we have a clash test widget here, which will potentially show the lists of tests as you create them. I also have created some buttons, and the button names are self-explanatory. I have hooked up the create test button to make a post call to the test API to create a simple clash detection test. Before I press that button, let's review the test API and the request body itself. For the test creation API, I need to supply the project ID under which the test needs to be created. I'm supplying the iTwin ID here, followed by the display name and description. There are two groups that I mentioned before, set A and set B, and in each of these, I can either provide the model IDs or the category IDs or an optional EC-SQL query to identify the elements. In this example, I have used a category ID for set A that corresponds to OBM caps, and in set B, it corresponds to OBM girder concrete. You can get the models and categories data for your iModel using the Models and Categories API. I'll share the link to the same. Or if you have an active iModel connection, retrieve it using the iTwin.js library. Rest of the properties can be updated if required. Ideally, in your application, you can build components to allow the user to specify these properties through a test creation dialog box. Getting back to the application, I have placed a breakpoint in the debugger for the post request I'm making to the Create Clash Test API, and I'll go ahead and click the Create Test button. As you see here, I'm making a post call, supplying the access token with the required scopes, and in this case, I need clash detection :modify. As I'm creating data, examining the request body, looks like it's good, and I'll go ahead and step over. Now in the clash test widget I have here, we see the test we recently created. To populate this widget with test data, I use the get operation on the clash test API, and it returned me the test I created for this iTwin so far. The next step is to run this test. Running the test implies using the test configuration that we created just now and applying it to the iModel and a desired named version. I'm in the documentation page for the clash detection runs subgroup, and if I scroll down, we can review the request and the response body for the run test operation. We need a test ID, which we have access to from the previous step, and an iModel ID and a named version and an optional test settings parameter. The named version can be retrieved from the iModels API, which is outside the scope of this session, but I'll share the link in my slides. For this demo, I have prefetched the named version I'm interested in, and the next step is to issue a post request to the clash detection test runs API. When I run the test, a clash detection job is scheduled on the server and provides a run ID in the response. I can then use this run ID in the run API to get more details of the run itself, like when was the test executed, the status, a clash report ID marked as result ID here. So I could build a UI widget that lists the test runs for a given test. Once a clash test is run, I would be interested in retrieving the clash report. And to do so, I would need the result ID that is returned in the response here, and the result ID can then be used in the clash detection results API to retrieve the clash report, which would contain the list of clashes. With that background, I'll switch over to the code editor and uncomment a few more code snippets. I'll uncomment the clash review table widget provider and the clash review test runs widget provider. Hit save. The two widgets are basically table widgets that are populated with the data from the test runs and that results API. I have switched over to my application and I see that there is a new clash test runs widget here and a table widget at the bottom of the visualizer, but they are empty at the moment. So let me go to the test widget and press the run test button, which issues a post request to the runs API. As the UI refreshed, I see that in the runs widget, the run data is displayed. Also at the bottom of the screen, the table widget shows the clashes from the clash report retrieved for the run. In this report, each row contains a pair of elements that are clashing with each other, and the data says that it's a collision clash, meaning they're physically clashing with each other. It also shows the category the element is part of. Since no suppression rule was applied to this test or run, there is no suppression data in the clash report. Now selecting one of the rows, I can zoom to the clashing pair and review the clash and potentially create an issue or a defect for tracking purposes. So to summarize, until now, we have been able to create clash detection test, run it, and review the results. It can so happen that some or all elements in this given clash report may not be real clashes, meaning in some scenarios, it may be acceptable for a type of element to be in contact with the other, and that may be part of the design. In such a case, we can mark those clashes as suppressed by creating suppression rules and associate them with the test. The suppression rules are basically EC-SQL queries and can be created using the suppression rule API to identify elements that can be marked as suppressed, and they'll show up as such in the clash report. I have switched over to the suppression rules API documentation. There are a few standard templates for suppression rules that are available, and as a user, I can either specify the category, models, or EC-SQL query to check for certain property values based on which clashes can be marked as suppressed. The templates for suppression rules can be retrieved using the Get Suppression Rule Templates API. Let me run this API and review the response. I'll supply my iTwin ID here and execute. Looking at the response, each template has an ID and defines a format, or rather a schema, for the user to supply the relevant data. For this demo, I have created a suppression rule that will mark clashes as suppressed if it is part of the OBM_caps category. I have now switched over to my editor. I'll uncomment the code snippet to activate the widget that shows the list of suppression rules created for this iTwin. After a UI refresh, I can see that the rule is created. Now I'll go to the Clash Test widget and press the Update Clash Test button to update the test to reference the suppression rule. The Update Test button issued a put request to the Clash Test API with the request body that includes the suppression rule ID that has to be referenced. I'm back in my application. I'll go ahead and run this updated test, and once this test is complete, the clash results table should be updated with the new clash report that indicates the clashes suppressed by the suppression rule, if any. Okay, the test run is complete. It shows up in the Clash Test Runs widget here because it has the updated name to reflect that the test was updated with suppression rule and has a later execution time. As you see in the Clash report table at the bottom, the rows which contain elements in the OBM_caps category are marked as suppressed. This concludes the demo. To summarize, in this session, we reviewed the clash detection API and went over how to create a clash test, run a clash test and review the results in the table and the visualizer, associate a clash test with a suppression rule, and run the test and review the results with suppression data. I have compiled a list of links that would be useful to the audience. The clash detection API, which we touched on some sections in this session, some samples and tutorials related to clash detection, the iModels API, which was used to retrieve the named version of the model, platform portal if you need to reference other platform offerings, and community support links. Thank you for attending this session.